For a while now, we have been talking a lot about classes and mutation and aliasing and things to that effect. So now I want to propose a separate issue here. So let's say that we have a set of classes, like for example cat, let's say we have a class dog, and let's say we have a class cow, just for example. So we want to define that each one of these classes can speak. Okay? So all of these classes can speak in some way. So how can we do that? Well, one thing we could do is just have, like, let's say that there's a method called speak that returns a string that represents what that animal does when it speaks. Okay? So for example, in the cat class, the speak method might return the string meow, just for the sake of the example. And we could do the same thing in dog. It might say woof when it speaks, and cow might do moo. I don't know. Just something. The idea is that each one of these classes will inhibit some behavior that is defined, that we define in one way or another. Okay? So each one of these classes has this method called speak. But now let's say that we want to combine everything that can speak and put it inside of a list. Okay? So there's a big issue to start off with here, and that is, what type do we put as the generic type qualifier? Well, we obviously can't put separately cat or dog or cow, because then we wouldn't be able to put instances of the other objects inside of it. So we might have a list of animals, and this is a new array list. And then we might want to do something like add new cat with maybe some fields or something, I don't know. List of animals, add new dog with maybe some other fields. List of animals, add new cow, so on and so forth. Okay? And then what we want to do is, let's say we want to see what calling the speak method on each of these objects would do. Well, we might traverse over this in some type of way. So for every animal or something in this list of animals, we could call we could do sout system out print line, and then do t dot speak. Okay? But there's there's a really big issue here. For one thing, there's no way to do this at runtime. Well, okay, there technically is a way to do this, but with the stuff that we've learned so far, there's no way that we can do this, because this requires some introspection, so to speak, on what methods that these classes have, and there's no way that we know of, at least, to do that. But what we want to say is that there is some behavior that is, we're going to say speaking. Speaking is some type of behavior that a class can implement that we can then define by putting instances of that into some data structure. So that was a lot of fluff there for the notion of something that we are going to call an interface. Okay? An interface is a mechanism for packaging behaviors of an object or a class. Okay? It's a mechanism for packaging behaviors of an object or a class. Okay? So what is that behavior that we want to package up into that other classes can then use? Well, that behavior is something that we're going to say means that they are speakable. Okay? So all of these animals are, or they behave like things that can speak. Okay? So most interfaces, when you define them, are adjectives. So they inhibit the behavior of being speakable. Okay, they are speakable. I guess maybe this is a noun. It doesn't matter. Interfaces are generally adjectives or they are nouns. Okay, so speakable is a characteristic of those three classes. Okay, so cats, we're going to say dogs, and cows, they all are subtypes of speakable. Okay? And what this means and what this looks like in Java is that cat, dog, and cow will implement some interface. Okay? And so I'm going to go ahead and just add on a point here that we are going to define interfaces as being prefixed with the letter I. And that's just a convention that sometimes you'll see people in Java doing. So we're going to say that cat implements the I speakable interface. And what this means, like I said, is that this means that cat inhibits the behaviors of being speakable, or it behaves like something that can speak. But what exactly does it mean for something, a subtype, to speak? Like, what does that mean? We haven't said that yet. So we're going to say what that means. An interface comes with methods that must be overridden by a subtype. Okay? So we have some interface here. This is how you define it. You say interface, which is a keyword, then the interface name, iSpeakable. Then we have, inside of that, we have a bunch of methods that don't have bodies. Now, what does that mean exactly? That means that we want, so let's back up and think about what this interface should represent. It represents something that can speak. And speaking means that it will have a method called string speak, okay, that receives no arguments, and we do not provide a body for this method. Why do we not provide a body for it? The reason why we do not provide a body for it is because inside of the, let's say, the cat class or the dog class or the cow class, the class is going to override the speak method and provide an implementation for it. Okay, so sorry about that, I had to make a quick cut. So let's switch over to Java, or the IDE, and let's actually write the cat class. So I've got some other stuff set up here, but we will go one step at a time. So let's just say that a cat has a name and an age, okay? And then it receives these by parameters to the constructor. So these should be very straightforward to write. They should have, you should have no trouble doing that, okay? Now, let's define an interface for each of these animals. So we'll also say that we'll have a dog class, and we'll just say that those also have a name and an age. And we'll just say that cows, for whatever reason, do not have an age, or we just won't store an age for cows, okay? Just to make it slightly different, okay? So now let's make an interface. How do you make an interface? You make an interface by clicking on, right-clicking on source, new Java class, select interface, and then type iSpeakable, or rather, you'll type the name of the interface that you want to define, okay? So here's what we had in the diagram. So we'll do string speak. This is the method that for anything that implements the iSpeakable interface, it will need to provide an implementation for the speak method. So what exactly does that look like? This means that if we implement the iSpeakable interface, we're going to get an error here. It's going to say that it must define speak. Okay, so it says some other stuff here, but we will cover that in a couple of sections. So for now, all this says is that we need to implement this method. Okay, so if you want to go with what IntelliJ is saying, you can just you can hover over the error, click Implement Methods, and then hit OK. Now, you're going to get some stuff here in the Java doc that you should fill out. We are not going to. But now we have this override public string speak. So we know what override does. We've talked about that with dot equals, dot hashcode, and dot toString. That should be pretty familiar. Okay? But it may not be familiar in the context of an interface, and really you don't need the override at all. All this is saying is that we are providing an implementation for the speak method as it comes from the iSpeakable class. But really the override isn't that important here. What is important is this public keyword. There are two instances that I said where public cannot be omitted. You cannot omit it with dot equals, hashcode toString, and this is the second. The second is with any interface method. All interface methods are implicitly public. Even if you don't say that they're public, you have to put the public keyword here, otherwise it will not work correctly. Okay, so let's do that. Now let's actually define how a cat can speak. A cat can speak by saying meow. That seems fine. Now let's do the same thing for dog. So it implements iSpeakable. It will override the method. We'll say it returns woof. And then for cow, we'll say implements iSpeakable, implements override, get rid of that, return, let's say moo. Okay? Now we have some mechanism for combining all three of these classes into one unit, so to speak. All three of these subtypes, cow, dog, and cat, implement the iSpeakable interface. And what that means is that when we're testing this, we can create a list of iSpeakable objects, and we'll say that we have a cat named Butterscotch. We'll say that she is 4. We have a dog, let's say Lucy. We'll say 10, and a cow. We'll say Betsy, I guess. So we have a list of iSpeakable objects. So we can pass anything into this list that implements the iSpeakable interface. That is what this is defined as. Then we can loop over each of these objects by saying for every animal, for every iSpeakable object in this list, we're going to call the .speak method. And as you can see, when you hover over this, this will contain all the methods that you can call or that are defined as a commonality amongst all of these objects. What is that commonality? That commonality is the iSpeakable interface, and inside of that we have a speak method. Okay? So if these classes did not have some overarching thing, for example, like we have iSpeakable, and then each one of these classes behaves like or is a kind of iSpeakable. Okay, so we said cat, we said dog, and we said cow. Okay, that's how we can combine all of these classes into one thing. And if we run this, now it's not a JUnit test, but that's fine. We see that it outputs the correct data. Now you may be wondering, how does this know which speak method to call? Because we're just saying that these are iSpeakables. We're not saying that this is a cat or a dog or a cow. I mean, we are. We're saying that as we add them to the list. But when we call .speak here, we're calling it on an iSpeakable. We're not calling it directly on a cat. So what's going on here? What's going on here is something called dynamic dispatch. So at runtime, Java will figure out which type of object you're calling the .speak method on. So what type of object is it actually instantiated as? Okay, so we say that iSpeakable, or rather we have a list of iSpeakables, but that's what they're declared as. They're not instantiated as iSpeakables. So we could do something like iSpeakable cat1 equals new cat, and then pass in, let's say, the name of some cat, like this. And we could do the same thing for, a cow. You could say new cow, and then just some other name. This seems fine. But one thing you can't do is something like I speakable, I speak equals new I speakable. Okay? The reason why you can't do this is because it doesn't make sense to create an instance of an interface. An interface is a mechanism for other classes to implement and provide, well, an implementation for. Okay? So, to kind of just summarize what I said, Java will, at runtime, figure out what type of object it was instantiated as and then call the appropriate .speak method. That idea is called dynamic dispatch, but there's a related concept called polymorphism, and I'll explain this in greater detail in later videos, but the idea is that each one of these subtypes defines speak in some way, right? They all do it differently, though, but they all have the behavior of speaking, okay? The poly here means many, morphism referring to behavior, or morph referring to behavior, okay? So, many ways of doing the same thing.